Hello everyone, welcome back again for another virtual instruction wherein we will be covering activity 3 for illustrating polynomial functions. Let us immediately go to our first example. We have the function of x is equal to 5x squared minus 3x raised to 4 minus x cubed minus 2, and we are going to determine the degree, the leading term, the leading coefficient, and the constant. And obviously from this example, we can say that the leading term is negative 3x raised to 4, wherein its degree is 4, and at the same time, the leading coefficient is negative 3. And the term without a variable x is negative 2, therefore our constant would be negative 2. For the next example, we have the function of x is equal to 2 times the binomial x plus 3 times the binomial x plus 1. There is a more efficient way on how we can determine the leading term, the degree, the leading coefficient, and the constant for this kind of polynomial function. But first, let us try the long one. Let us expand 2 times the binomial x plus 3 times the binomial x plus 1. But first, we multiply the binomials x plus 3 and x plus 1 by applying the FOIL method. So we will have x times x is equal to x squared, x times 1 is equal to x, 3 times x is equal to 3x, and 3 times 1 is equal to 3. From this, we will be combining x plus 3x since they are like terms. Thus, we will have 2 times the quantity x squared plus 4x plus 3. And now we distribute positive 2 to each one of the terms in our parentheses. So we will have 2x squared plus 8x plus 6. Going back to the table that we are accomplishing, we now use 2x squared plus 8x plus 6. And obviously we have the leading term as 2x squared, and from this we now have the degree which is equal to 2, and the leading coefficient is 2. And from the same given, we will have the constant equal to 6. And the easy way to do this is to go back to your original polynomial function. So let us again consider the function of x is equal to 2 times the quantity x plus 3 times the quantity x plus 1. Observe that we can get the leading term by just multiplying the factor outside and then the two variables in the binomial. So we will have 2 times x, that is 2x squared. Okay? Also, we can get the constant by just simply multiplying the factor outside and the constants in the binomial. So we will have 2 times 3 times 1, that would be 6. Now, for the third example, let us apply what we have observed from the second example. So we have the function of x is equal to 3 times the binomial x plus 3 squared times the binomial x plus 1 squared. By expanding this, we will have 3 times the binomial x plus 3 times the binomial x plus 3 times the binomial x plus 1 and times the binomial x plus 1. To get the leading term, we will just have to multiply 3 times x times x times x and times x. So we will have 3x raised to 4. And we can now already establish that the degree is 4 and the leading coefficient is 3. And for the constant, we are going to multiply the factor outside 3 and then the 3 here in the first binomial and another 3 in the second binomial and 1 from the third binomial and also 1 from the fourth binomial. So we will have 3 times 3 times 3 times 1, which is equal to 27. And that is how you can accomplish your activity 3 for week 1 to 2, which focuses on illustrating polynomial functions. Thank you for watching and stay tuned again for the next virtual instruction for another set of activity sheets.